The purpose of this video is, on the one hand, to highlight the many advantages of dynamic simulation for efficiency improvement in operations and supply chain management, and on the other hand to introduce the IPros digital operations platform. After a short introduction, 4 industrial cases are presented. Almost every single industrial company is confronted today by an increasingly more difficult business environment, such as a volatile market demand that makes forecasts more and more unreliable, a predicting demand for new products, which is like looking into a crystal ball. On supply chain level, lead times are still too long and disruptions make the situation still more complex to manage. Sharp competition implies high service level, which is often obtained through costly distribution channels. In such a challenging situation, the main issues can be summarized in 4 main topics on 3 management levels. First, on the strategic level, designing a robust and effective distribution network, formulating a risk-resilient strategy for new product introduction. Second, on the tactical level, dimensioning the supply chain so as to obtain an optimal ratio of service level over cost. Third, on the operational level, operating reliably under high uncertainties, on the market, as well as on the supply side. Under such a complex situation, complicated by the very dynamic nature of supply chain, thoughtful decision cannot anymore rely on experience and intuition. These good times are gone. Modern digital technology is now powerful and accessible enough to support decision makers and help them deciding on a safer basis. Agent-based dynamic simulation represents a powerful and reliable way to model the high variability and dynamics of the real industrial environment. However, the development times and costs are often too high to respond quickly and at a reasonable cost to real decision situations. The IPros digital operations platform has been developed to alleviate this problem. It provides pre-programmed modules, Lego blocks, capable of simulating all major supply chain functions and all main management policies. Without going into details, the main features of the IPros digital operations platform are: the ability to simulate many customer-supplier relations, support decision-making at strategic, tactical and operational levels, test scenarios in the framework of a what-if approach, incorporate case-specific constraints and policies, precisely model real-life stochastic behaviors and uncertainties, allowing to evaluate different supply and distribution strategies, take into account the many products and items of the company, test all possible inventory and material flow management policies. Let's now look at 4 different trial cases, which were resolved thanks to the IPros digital operations platform. Case 1 is related to the pharma industry. Here, the main challenge consists in the absolute necessity to maintain a high service level under cost constraints. The situation is characterized by non-optimal network and consequently by the necessity to evaluate alternative network designs. The approach used consists in leveraging the capabilities of the IPros digital operations platform in order to, at the strategic level, test the performances of various alternative network structures. At the tactical level, dimension the management policies of the selected network. The current supply chain design consists of a central factory producing standard-based products and differentiating them for each market. The central factory, as well as all raw material suppliers, are managed using a standard push, MRP-based system. The central factory carries a raw material and a finished, differentiated product inventory. These inventories must cover uncertainties in transportation and production, as well as the forecast error. Each of the distribution centers carries a small buffer inventory covering the upstream transportation uncertainty. This buffer inventory is managed in a pull mode with a simple SS policy. A first alternative design, called X, consists in a central factory producing only standard-based products, leaving the market-specific differentiation to the distribution centers. The central factory, as well as all raw material suppliers, are managed using the same standard push, MRP-based system. Upstream, It carries the raw material inventory, as in the current design. However, downstream, it has just a reduced buffer of finished, standard products, which covers the uncertainty in production. Each of the distribution centers carries an inventory of standard products covering the transportation uncertainty and the forecast error. This inventory is managed in a pull mode with a simple SS policy. A second alternative design, called Y, consists of a hybrid solution. There is no difference with Design X concerning the central factory. However, the distribution network shows a mixed structure consisting of 3 centers with differentiation capability and 2, Singapore and Thailand, without. Consequently, the South Korean distribution center becomes the supplier of differentiated products for these 2 countries. The 3 distribution centers with differentiation capability carry an inventory of standard products covering the transportation uncertainty and the forecast error. The distribution centers in Singapore and Thailand carry only a small buffer inventory covering the upstream transportation uncertainty from South Korea. All of the distribution center inventories are managed in a pull mode with a simple SS policy. Using the IPros digital operations platform, a specific decision support tool, targeted at the particular supply chain design situation is developed. It contains a customized interface, exhibits major KPIs such as service level, cost elements, inventory levels and product flows. All of these elements appear dynamically to the user, facilitating the understanding of the outbreak of unexpected situations. The performances of the 3 alternative supply chain designs can be reliably compared after dynamically simulating each of them. It appears clearly that supply chain 3, with design Y, exhibits the best performance over cost ratio, with a 20% cost reduction, while maintaining a 99% service level. Thus, the hybrid structure, with a Central Asian differentiation center constitutes the best of the 3 alternative designs. Case 2 relates to the deployment of products along the supply chain for the launching of a new strategic product in the pharma industry. The imperative challenge consists in assuring the availability of the product on the market immediately after its launch, this in a context of totally unknown demand. The situation is characterized by several hard physical constraints such as cold chain capacity and limited shelf life. Furthermore, the availability of the production for some key components is restricted by fixed manufacturing campaigns. The problem is solved by making use of the capabilities of the IPros digital operations platform at 3 levels. At the strategic level, use a what-if scenario-based approach for evaluating the robustness of decisions with respect to possible market demand evolutions. At the tactical level, define the evolution of the inventory management policies for various possible demand scenarios. At the operational level, compute the optimal minimum order quantities for packaging for various demand scenarios. The case is focused on the US market and 3 demand evolution scenarios are considered for evaluation: a scenario with low forecast error, a scenario with a 20% over forecast and a scenario with 20% under forecast. A customized interface is developed for supporting fast adoption by the user and facilitating the task of the decision maker. The supply chain performances related to the 3 demand evolution scenarios are obtained by dynamic simulation. They show non-significant differences. This indicates a proper calibration of the supply chain that is not meaningfully affected by the large forecast errors. Consequently, the supply chain calibration is robust enough for responding to the unpredictable market demand evolution that characterizes the launching of a new product. Case 3 reveals how dynamic simulation remarkably enhances training and enriches educational programs. The case considers the manufacturing of a complex electronic product with a multi-level bill of material and several manufacturing and assembly operations. The main pedagogical objectives are: learn by testing and experimentation the differences between push and pull management policies and or Kanban loops. Learn how to calibrate management policies in order to obtain good and robust performances. grasp the impact of operational decisions on the evolution of the stock levels. To reach these goals, a dynamic simulation model, based on the IPros digital operations platform is used. It allows, among others, visualizing and observing the dynamic behavior of the whole value chain, from the supply chain level to a single manufacturing operation. Furthermore, the assessment of manufacturing and supply chain strategies, such as push or pull, is facilitated by the availability of many cost elements. More specific, the user can create a customized control panel or user interface to define the management policy, production plan, calibration, and various other parameters. Design and visualize the network. To get a visual overview of the whole value chain and the interrelations, we can call it a digital value stream mapping. To track your network from a facility up to a component level. To combine your products by segments and assess the selected KPIs. To assess also the studied case at a product level. Or to investigate the financial performance of the solution and review the cost breakdown. Case 4 illustrates the effectiveness of simulation and change management. It concerns a program, co-developed with a watchmaking company's strategic projects team, as well as the lean manufacturing team. The objectives were both strategic and tactical. On the strategic level, the aim was to promote a product-based thinking for the selection of management policies and to extend the use of pull rather than push approaches. Furthermore, resistance barriers had to be broken in order to promote a spirit of critical assessment and continuous change. On the tactical level, the goals were to reduce stocks, to increase the robustness of operations, and to improve the supplier selection process on the basis of a multi-criteria approach. The change management program starts with a confrontation to the current situation characterized by the extensive use of a standard MRP-based push approach. The participants calibrate the system, observe its behavior, and assess its performances. The participants switch then to an operation based on a pull management flow. Again, the system behavior and performances are observed live during the simulation and assessed later. A specifically designed interface allows the user to examine any location of the value stream. In a nutshell, the IPros digital operations platform can be an ally for strategic and tactical decision support, operational support, or in training and change management. Thank you for your attention. We remain at your disposal for any questions. Looking forward to a constructive, efficient, and professional collaboration.